Now, of course, I'd like to invite our second speaker, Marc Goichot. He will be talking about nature-based solutions, testing and scaling in the face of challenges facing deltas, and of course, hopefully we will get better insights.
Thank you for the opportunity. Thank you for the discussions. I very much enjoyed them. They resonate. I've inherited this title in the abstract from my colleague Christopher Ho, who was supposed to be here and present. I accepted the challenge to make the presentation on his behalf. If I understand the instructions I get from my co-chairs, I'm supposed to be thought-provoking to generate discussion. I'll try to do that and not overdo that, but I apologize to this distinguished scientific assembly for the simplification that may occur in doing that. It's not a picture for Delta, but as many other presenters hinted, what is happening in that section of northern Laos is very important for the future of the Delta. The challenge that we're trying to address with scaling up NBS, for WWF, the key reference is the Living Planet Index that shows the loss of vertebrate species abundance since 1970. And you can see that it is in the freshwater biome that the sixth mass extinction is happening much faster than in the forest in the ocean. Very much the case in the Mekong. So the Mekong is the third most fish abundant river on the planet after Amazon and Congo. It is also a home to the most productive inland fisheries in the world. Also, the largest wildlife migration on the planet, more than a Mara. 5 billion fish move from the Mekong to the Tonle Sap every year. So we've tried to highlight, and those species are disappearing before they are described. So there's a key challenge there. We did this publication last year about the forgotten fishes to get a bit more traction. And actually, we were very surprised that we got a lot of traction in 1 billion view on this report. So people care about the fish, and that's good to hear. But still, there are challenges. Koen Boussadi, the CEO of the MRC, mentioned yesterday the report that is the key flagship report from the MRC, the State of the Basin report. This picture is taken in last year's regional stakeholder forum of the MRC, and we're discussing the key results of that report. Basically, in a nutshell, socioeconomic benefits have been realized at a very high cost for environment. All the environmental indicators are in the red, and the themes that come out are the themes that were discussed in the previous session, the dry season flow, reduced reversal flow to the Tonle Sap, to sediment reduction, more extreme weather. We saw in the presentation yesterday that on an average, there's not key change, but it's how this is distributed through the year that is an issue. And then, of course, the impacts of infrastructure. I like to put things in the perspective of adaptation. And I like to use this UN World Meteorological Organization report from 23 that looks at the cost of weather-related extremes. So first of all, it's very much what we're discussing. It is floods, it is droughts, and it is storms that are the biggest challenge. When you look at this graph, we are going in the right direction from a fatality perspective, which is very good to know, but the same data plotted against economic losses gives a very different situation, and the trend is not good. That's very interesting to see both, so we should continue. It should be our first priority to save lives. But the result of this, according to the report, is early warning systems, not infrastructure. Infrastructure is costly and not delivering. So basically, that gives us the space for new ideas and gives us also the macroeconomic rationale for thinking NBS at scale. Because the report says that we are expecting, in terms of GDP, for many countries in the world to spend more than 5% of their GDP to lost and stranded asset from those disasters. How does this resonate in the Mekong? So the Yagi typhoon that hit the region last year, there's a back-in-envelope calculation from the government of Vietnam, $3.3 billion direct cost. The same year in the Mekong Delta, there was a drought, and they have about the same number, so we are more than 1% of the GDP of a middle-income country of 100 million people. The 2011 flood in Thailand costed $46 billion, so it's 12% of the GDP of another middle-income country. Very interesting study from McKinsey looking at the direct impact of a 100-year flood on real estate, so direct real estate, Ho Chi Minh City. And they expect, so that was about 0.3% of the GDP of the largest economic hub of Vietnam, but they expect this in the next 30 years to be multiplied by 10. So not only are we getting more 100-year floods, but they're going to cost 10 times more. So again, we have a rationale to think differently. Why does an NGO working on conservation worry about that? Because we're losing freshwater biodiversity, we came with a freshwater biodiversity emergency recovery plan, and we looked at the key reasons why we are losing freshwater biodiversity. And it's connectivity. It's basically rivers being fragmented, sand mining, and again, the inability of rivers to flowing freely. So basically, it is the same reason. It is those infrastructure that are failing from a macroeconomic perspective that are the key reason why we're losing freshwater biodiversity. So that's our rationale to work on this. So what is the opportunity for us to work? The understanding that the values of rivers. So I see rivers when many people see water. So the value for biodiversity is being elevated, and the Freshwater Challenge is a good example out of Ramsar COP, country-led initiative that went to the biodiversity COPs and the climate COPs and came with the most ambitious ever objective to conserve or restore 350 million hectares of wetlands and 300,000 kilometers of rivers. 54 countries have signed to it. Food security and food, we know that floodplains and deltas are on average 6 to 8 times more productive than other land from a product perspective, and then wild fisheries are probably the most cost-effective way, a sustainable way to produce protein. There are the cultural values are coming in. They are very important to people, very much in Thailand, for instance. Recreational values, but also the connected river and all those services that are associated with floodplains and deltas are coming up. Very interesting also is the future for infrastructure. So this is a non-published UNEP view, so take it for what it is with caution. But 75% of the infrastructure needed by 2050 doesn't exist yet, and most of it will go to Africa and Asia Pacific. Interesting also from a population perspective, we talked about the greater Mekong, 300 million people, but most of them don't associate with the Mekong because they're not in the Mekong. So this is evolution of the human population from 75 to 2023, and then a projection afterwards. So the Mekong is not really populated except for the delta, and so there's 60 million to 70 million plus people. So there's an opportunity there. The places where you have the most rainfall are the people, and the flash floods are the places where you have the less people, so the more forest. There's also, from a floodplain perspective, those floodplains are rare in Asia for their low population, so they're relatively functioning floodplains, which is an opportunity because the key problem of flood elsewhere is that we have allowed non-floodable activities in floodplains. So we have this opportunity now to grab. The concept of river connectivity is key. So we published a paper in 2018 that tried to simplify the concept of connectivity that many people understand. So the concept of environmental flow, so longitudinal movement from water, energy, sediment, and biodiversity from upstream to downstream. But we add the connection between channels and floodplains, and also the vertical dimension, which is important with the atmosphere, with the groundwater, but also the incision in aggradation connected, so the changes of elevation of a riverbed. And try to put this all into one paper, in one index. We succeeded in doing this. The paper was cited more than 1,300 times, so it means a validation by science, but now the challenge is to transform this, as we discussed earlier, into policy. And our assumption is that a connected river is a cost-effective way to build resilience on top of protecting for biodiversity. We, in the same paper, did a mapping of all the world rivers in terms of connectivity, which allows to add to water or river managers to add to the concept of flows and concept of water quality, and it gives a simple reading and a good way to set, to think a bit differently, but also to set it very much resonates with what we've seen in other presentations in terms of room for rivers or room for floods, and when we talk about deltas, but also the importance of sediment, because sediment is key to sustain the delta. We all agree and discuss this at Hanks. I did this slide in relation to the discussions we had yesterday on what, why rivers have deltas and bigger and some don't. I use the case, so it's the relation between the area, the size of the basin, and the size of the delta. So the extreme case is the Irrawaddy in Myanmar, which generates a lot of sediment. It's a relatively small river, it generates more sediment than the Grancha Brahmaputra, more than the Mekong, so twice more than Mekong for a river that is half the size. So basically, the ratio about the 23rd basin in terms of area generating or creating the delta that is the 11th. We can look at the Mekong also, so the 17th delta, 17 river in terms of river basin area created the third largest delta. So it is a matter of the ratio between how hard working the river is by generating sediment and the conditions, the forcing agents in. So I will risk to also point at what I call now lazy rivers. So rivers that are not creating large deltas despite having a large basin. So I hope I don't make people unhappy because the Nile is there, but the Parana is a very lazy river, I'm sorry. So the approach, basically, we have relatively good scientific evidence that NBS is a cost-effective way of addressing those societal challenges that we're looking at, notably adaptation and disaster risk reduction. The problem is that it only delivers if you do it at scale. And the problem is it has never been done elsewhere. So we have an issue to create generate the financing that we need at scale for something that has never happened before. So that's the key challenge that we have. So what we try to do is to be more strategic in identifying NBS and developing them and looking at the potential for upscale. The problem if you want investment, you have to have some very tangible returns on investment when many stakeholders have less tangible expectations. And we're drawn by what is easy to measure. So it's not because it's easy to measure that it's important. It's not because it's difficult to measure that it is not important. So that's a big challenge. And then the issues of scales also that we discussed yesterday, the fact that it has to work for communities, it has to work for the basin, it has to work for all stakeholders, which is a difficult challenge evaluation. So we are only scratching the surface with that problem, but something that is worth discussing. So try to be strategic on where we do NBS pilots, because there's many pilots, but part of the discussion also, question when you have an NBS, the first question is it has to work for a local community, but you have to ask the question, what happens if you multiply by 1,000? So what we did is we identified 6 key zones that are geomorphic zones that would need to have a model that works, and that will define the area that you can upscale it to. So the watersheds, obviously, to reconnect the tributaries and the floodplains. Sand mining is important, and I'll get back to this because it has an indirect impact on exchanges of the energy in the river exchanges with the floodplains. Rock-based channels are a very specific feature of the Mekong. That is where the substratum is very close to the surface, so it's very resilient on one side to changes, but also important to address. And the connection with the floodplains and the huge opportunity we have in Cambodia, and then the delta itself. I will not go through all of them, don't worry, but I'll just I will just pick on a couple. So first, so basically the problems that occur when you disconnect the floodplains from the floods. And what we tried is to demonstrate a model of flood-based agriculture and to look at those models. First of all, from a purely financial perspective for the farmers and for the users, and see and test this model of what will be the values of reconnecting the floodplain. So we tested this on 1,000 hectares in Lang Sen. So it's the upper delta on the eastern side. Have a model that works. So it works for communities, it works for the supply chains. So we have a model, and it works also from the perspective of basically a high-level storage, water storage, which is what we want to value natural storage, and the system is more effective than others, less than the floating rice that was mentioned yesterday. That is another model. But and again, from a sedimentation perspective, we have a model that captures much more sediment, which is the only way to compensate for subsidence. So the model works in perspective at this very high level reference. And then we look at the scaling up and the potential. So the suitability. So this 1,000 hectare has the potential to be scaled up at 300,000 to 400,000, which is not bad. But what is interesting also is the places where it doesn't. So and it means it indicates where we have to find a different model. Looked at a very interesting case in Thailand. So it's a small 2,000 hectare wetland that is that has been optimized, so disconnected to the river to optimize rice production in the hands of the Royal Irrigation Department. Local communities, so it's a Ramsar Sad, so local communities see that there's decline in fisheries, decline in wildlife, and they have issues including with invasive species, and they think it is linked to disconnection. So they are the drivers to ask for reconnection, and we worked with them to engage different departments, and now the Water Resources Department is there with the wildlife, and we brought the Royal Irrigation and agree in principle to reconnect as a consensus. So it's a good example that we use and to upscale one that is community-led. So that's the plan to reconnect and address the key challenges. Sand mining. I will simplification again, an old slide. So this is the Tonle Sap, the Tengchamuk, so Phnom Penh juncture. And what happens? So the key problem of sand mining is riverbed incision. So the riverbed incision I was mentioned in the modeling this morning between Phnom Penh and the sea is 2 to 3 meters. In the past 20 years, there may be issues upstream. But what happens if you have riverbed incision? So less inundation of the floodplain, obviously. World water recharge, I assume, I don't have data, but I think from infer discussion that this is an issue. But it affects directly the relationship to the Tonle Sap. And if you do that, we know that the world fisheries is directly related to the length and the duration of the flood. So if you have less, then you have less fisheries production. And if you have this, then you have less buffer role, it was mentioned this morning, so you expose the Mekong Delta to more damaging floods. You may change the conveyance between the two channels. That has something. It exacerbates riverbank erosion, coastal erosion, salt intrusion, all of those were mentioned this morning. So we had this report that was triggered by the Department of Climate Change of Vietnam and AFD and other researchers on the climate delta emergency that was presented in the COP27, and for the first time ever we tried to synthesize and to look at the role of sand mining in climate resilience with a specific case of the Mekong. We worked with CEPER and what you do. So basically it's very difficult to act if you don't have monitoring, so it's very difficult to know how much sand you have in the river, in the delta, so we created the first a Delta Watson budget in collaboration with the Vietnam Dike and Disaster Management Authority on the MARD, and delivered the first very simple system. So how much sand comes into the delta, how much is stored, how much is extracted, and how much makes it to the sea. Very simple in principle, but that was the first time ever that managers had this, and that triggered a lot of changes. So sandbank, so that's the Can Tho, and the roll of sand that you rarely see, that's because low tide, and that protects the mangrove. So in conclusion, if you are in a situation where you're facing water and climate risk, you have basically three approaches. The first one is resist, dikes. That's the one that is usually used, and that's the one that from a macroeconomic perspective is not delivering. It's for us the reason for losing biodiversity. There's what I call the fatalist approach. You can retreat, you can relocate early warning systems to the crops. It works, it has social benefits, not so much conservation benefits, but I see it more as a transition. And then active resilience, working with large-scale natural processes. That's what we're trying to do. There will be no case of it's one against the other. It's always the three. But what we try to advocate for is more of the three, less than the one, and the two, more as a transition. And my last call is kind of an era revolution from DDD to CCC. We inherited a logic that we have to get the water as fast as possible out of the watersheds into reservoirs and into the sea. And we're advocating for making it work, because that's the only way to achieve resilience. And I'll end up by risking an adapted metaphor from the very famous book that Visconti made very famous with a movie. If we want the deltas to stay as they are, many things have to change in the river basins. Thank you for your attention.
Great, thank you very much. Thank you very much. Okay.